Hey guys, this is in addition to part 2 of 4.2 and 4.3. We're going to look at some proofs, and the proofs that we're going to be looking at right now use material from chapter 3 as well as material from chapter 1. So our first proof here, our given information, it says FG is parallel to KL, and FG is also congruent to KL. So we're going to write that in our first statement. Our reason it's given. All right, so what we're going to do now is we're going to write our marks, make our marks in our diagram from the given. We know that FG and KL, they are parallel. We also know that they are congruent. Now we're going to explore a little bit with this parallel idea. So what we have are two lines that are parallel. And then we are able to use this line, what I call in the middle here, that's between the two triangles, as a transversal. So we have two parallel lines, a transversal. And what we are able to say is that these two angles here that are alternate interior, they are congruent to one another using our alternate interior angles theorem. So I'm going to clean this picture up a little bit and add in our marks. And what we can say for our second statement is that angle LKF, that's the angle at the bottom, is congruent to our angle at the top, which will be GFK. And our reasoning here is that we know when we have parallel lines cut by a transversal, alternate interior angles are congruent, and that is our theorem for alternate interior angles. So if you're keeping track of our three, right now we have a pair of sides and a pair of angles. We also have these two triangles stacked on each other where they share a side in the middle. So we can say that FK, side FK, is congruent to itself, and that is reflexive. Which gives us our third piece of information. So we have two sides, one angle, and that angle is included. So that would make this side, side, side. So to finish up our proof, we know triangle FGK is congruent to KLF, and our reason would be side, angle, side. So it's very common when we are working with proofs and we see parallel that you may use this alternate interior angles theorem. You may also use some of the other theorems that were discussed in chapter 3 with parallel lines, but this one just is one that's a little bit more common than the others. For example 2, we have a lot of given here. It says that AE is parallel to BD. We also have that AE is congruent to BD, and angle E is congruent to angle D. So we're going to add that information into our picture. We know that AE is parallel to BD. We also know that those are congruent. And our angle here at the top of our picture, E and D, those are both congruent. And that's all based off of our given. So the given's actually pretty friendly to us here. They give us 2 out of the 3 pieces of information that we need. So we just need to find one more thing to use one of our shortcuts. And we're going to use these parallel lines along with the transversal as side AC. And what we end up here with is we have a set of corresponding angles here that we know are congruent based off of the parallel lines. So we're going to add that into our proof here. Angle A is congruent to angle DBC. Based off of our corresponding angles postulate. And that gives us our third piece of information. And we have enough information to prove that triangle AEB is congruent to triangle BDC. Based off of angle, side, angle. We have 2 angles and the included side for our shortcut there. So as I mentioned earlier, alternate interior angles is a very common theorem that we'll use with parallel lines, as well as the corresponding angles postulate. All right, and our final proof for this lesson, our given tells us we have AB is parallel to DC. And then we also have a second pair of parallel sides. AD is parallel to BC. So I'm going to put those labels in our diagram here. AB is parallel to DC, as well as AD is parallel to BC. So I'm going to start with the parallel on this example. So what we have is we have a pair of sides with a transversal that are parallel. And we could say that through alternate interior angles, angle BAC and DCA, they are congruent. And we can also use the second pair of parallel sides along with that transversal to say that the angles DAC and BCA are congruent as well. And both of those are using that alternate interior angles theorem that we saw in the first example. So we're going to write that in our proof here. I'm going to start out with BAC is congruent to DCA. And our reason was the alternate interior angles theorem. And I'm also going to include DAC is congruent to BCA. So that's that second pair that we found. For the same reason. So we're not going to have to write an additional step there. We're just going to include it because they use the same reasoning. So what we have are two pairs of angles. And then from our picture, we have our stacked triangles. And when we have stacked triangles, we know we can say that the side between them is reflexive. So for our third step, we're going to say that AC is congruent to itself because that is reflexive. And we have our third piece of information, which is the included side. So for our fourth step, we can write our proof and say that ABC, that triangle, is congruent to triangle CDA. And our reasoning here is we have the angle side angle theorem that is being shown and used. All right. So just some quick reminders from chapter 1 and 3. Some of the terms that you will see in the given that will be used in your proof. From chapter 1 will be things like midpoint, bisect, vertical, perpendicular, for chapter 3, anytime you see parallel, that will lead you to use some things such as the alternate interior angles theorem, as well as the corresponding angles postulate. We also may use alternate exterior angles theorem, or even same side interior angles theorem. Those are just not as common. All right. So guys, make sure you're practicing your proofs. If you have any questions, get in contact with me.